very good morning, dear students. We are in our module number 3. So, in the previous classes, what we have seen, as per your syllabus, we have covered the fundamentals of 8085 microprocessor, then its architecture, addressing modes, instruction sets, interrupts, and the development of assembly language programming. Okay, up to this topics were covered in the previous classes, and we were going through programmable peripheral interface 82555 and 8255 and the programmable interrupt controller 8259. Okay. In today's class, what we are going to see programmable keyboard and display interface, that is 8279. Then we will see the memory interfacing and the IO interfacing and also address decoding. Okay, this is what we are going to cover today. So let us see a recap of your previous classes. Is nothing but 82555 as well as 8259. So what is 82555? That is nothing but a programmable peripheral interface. So you are going to connect multiple devices to the 8255. Okay. So what is the main requirement of this programmable peripheral interface, or you can call it as a PPI? Okay, 8255, or it is a PPI. Okay. So the main importance is its feature is it's nothing but its port. Okay, there are 3 ports: port A, B, and C. Right. So the port A and B, it will be act as an 8-bit input-output port, and port C, it will be act as a 4-bit input-output port. Okay, that is the port A, B, and C. Right, that's what we have seen. Then what else we have seen? The modes of operation of this ports, that also we will see. That is nothing but the bit set reset mode. That is only for port C set or reset. Okay, the particular bit is setting or resetting, we are using bit set or reset mode. And next one is nothing but the input output mode. Input output mode, there are totally 3 modes are there: mode 0, mode 1, and mode 2. Mode 0, all the ports will be active in input output port. Then what about mode 1? In the case of mode 1, port A and B use the 8-bit input output port, and another thing is port C bits are used as the handshake signals for port A and B. Then mode 2, only port A can be working the mode 2 of operation, and the port B and C, port B must be working either mode 0 or mode 1. And port C, 5 signals will be used as the handshake signals for mode 1. And if port B is working in mode 1, then port C, 3 signal will be used for the handshake signal for port B. Otherwise, the port C, the bits will be act as the nothing but the input output port. Okay, this was the mode of operation. Then we have seen the pin description, architecture. So architecture, almost all the portions will be almost same. So the main thing is you have to draw the diagram, and also you have to explain. Okay, explanation will be almost the same only. It will be coming. So if the data bus buffer, read or write control logic, that portion will be available for all the features, all the devices, 8255, 8279, 8259, all the devices. So you can use the same input output or the data bus buffer and the read or write control logic explanations you can use everywhere, right? So the main feature of this architecture is it has a 2 controls. First one is group A control and second one is group B control. Group A control is nothing but group A plus port C upper, and group B control is nothing but port B plus port C lower. Okay, this is what you have to be remember. This is, you should not interchange the values, because this one is port C lower, and for group A it is port C upper. Right, this is nothing but the architecture of 8255. Then we have seen each and every blocks in detail. Right, that's what we mean 8255. Right. Next one is 8259. 8259 is fixed 8259, that you can call it as a programmable interrupt controller, because the main disadvantage of 8085 is it can handle, it has only 5 hardware inputs, interrupts are there. So if you want to add multiple devices with this 8085, you have to use an PPI kit. Okay, so sorry, PIC kit. that is programmable interrupt controller, that is 8259. So you can utilize in every PIC it has a 8 interrupt control will be there. So you can cascade it together, multiple PICs together, and you can make it up to 256. That is nothing but your 84 interrupt lines. So this is nothing but your PPI. So PIC 8259. Now this is nothing but the pin level diagram, and pin level diagram also we have seen each and every things in detail. Then we were going to the block diagram. Block diagram. So read or write control logic, data bus buffer. These two are common for 8255 as well as 8259. So you can use the same definition here also. This one is cascaded buffer comparator, and this block is used only for cascading multiple PICs. Okay, 8259 PICs. We have to cascade multiple PICs. We are using this block. Then control logic. Control logic is only sending interrupt to the CPU as well as acknowledgement from the CPU also. It will accept the acknowledgement from the CPU. Then there are major 4 blocks: interrupt mask register, interrupt request register, priority resolver, in service register. Interrupt request register, so it has 8 pins. So it will receive the interrupts from peripheral devices, and it is given to the priority resolver. The priority resolver will prioritize which interrupt it has to work first. Okay, that particular interrupt is given to the in service register. So in service register, which holds the address of the address of the interrupt which has to be worked out now. Okay, that is in service register. Then interrupt mask register, that is nothing but IMR. Here you can mask or mask means you can hide. Okay, you can hide a particular interrupt. That is nothing but your interrupt mask register. This is also what we have seen. Now, what we are going to see now is 8279 programmable keyboard. I'm audible, no, sir?
Yes, madam. You're audible.
Okay, sir.
Yeah, you can proceed.
So now what we are going to see is 8279, that is nothing but a programmable keyboard as well as display. Okay, that is 8279. So you have to remember all these names. It is not necessary to be asked in the sentence like question. You so explain the block diagram of 8279. So by the number itself, you have to be identify that it is a programmable keyboard. Okay. So 8279 is 8279. 8279 is a programmable keyboard, and 8259 is nothing but PIC, programmable interrupt controller, and 8255 is that is what to say, PPI. Okay, peripheral interface, programmable peripheral interface, that is 8255. So you have to be remember the by the name. So so we will start with the 8279 programmable keyboard. So what is the programmable keyboard will do? Actually, it is designed by Intel that interface the keyboard with the CPU. So what is the CPU will do? So you have a keyboard. Okay, you are going to press a key. So the CPU has to detect that you have pressed a key, right? That is what is the CPU is doing. So the keyboard first scans the keyboard and identifies if any key has been pressed. Okay, it will check whether any key is pressed or not. So if it is pressed only, that is identified by the CPU. Okay. So the corresponding response will be sent to the CPU and also vice versa. Right. So it will check every time the CPU is going to check whether any key is pressed in the keyboard or not. Okay. So if any key is identified, if any key is pressed due to pressure, okay, there is some pressure point will be there. So if any key is pressed, the CPU will identify. Okay, suppose if you press the key T, okay, so it has a standard technique that it is arranged in a row wise as well as in column wise manner. Okay, it is arranged in row wise and column wise manner. Then first it is checking which row the key has been pressed, which row the key has been pressed. Then it will check. So suppose if it is in row 2, okay, if it is you have pressed a key in the row 2, what it will do? Then it will check which column it has been pressed. In which column it has been pressed. So it will identify the corresponding row and column, and it is automatically identify you have pressed the key number, the key P. Okay, that is the way the CPU is identifying which key is pressed by you, the user. So the keyboard is interfaced by using two modes. First one is interrupt mode and second one is hold mode. Hold mode. Okay. So these two modes are used for identifying which key has been pressed. In the interrupt mode, whenever you are pressing a key, it is interrupting the CPU that I have pressed the key. Okay, so or the keyboard is telling the CPU that my key number P, suppose whatever it will be. So my key is pressed. Okay, it is informing the CPU that my one of my key is pressed. So then CPU will identify the key and it will continue the next task. Okay. But in the case of hold mode, what is happening in the hold mode? CPU is keep on checking. That is, it is in microsecond or nanosecond basis only. Okay. So it's based on the clock cycle. Clock cycle, you know what is clock and all. So it has an internal clock frequency. So based on the clock frequency, it is going to check. The CPU is always checking that any key is pressed. Okay. So and it is keep on checking that any key has pressed. So the CPU periodically reads the internal flag of the 8279. So internal flag is the 8279. If you are pressing a particular key, the corresponding signal, the corresponding code word will be generated in the 8279. Okay. So what is it will be do? It will keep on checking any key is pressed in the keyboard. That's what in the hold mode is doing. But in the interrupt mode, keyboard itself telling to the CPU that my key is pressed. That is interrupt mode. But in the case of hold mode, CPU is asking whether any key is pressed or not. The CPU is going to ask whether any key is pressed or not. But in the interrupt mode, keyboard will tell the CPU that my key is pressed. That is the difference between interrupt mode and hold mode. I hope you clear the idea of interrupt mode and hold mode. You guys are there?
Hope that two modes of operation is clear, right? So Madam has said about interrupt mode as well as a hold mode. Is that clear? Let us know. Yeah, there was a reply on the chat box saying yes, it is clear. Thank you, Riaz, for the confirmation. Somebody from A section? Section A? Is that clear? Yeah, Sedu, thank you. Yeah, Sudarshan. Yeah. Okay.
Okay. So we'll move. Now this is the architecture of your 8279 keyboard interface. Okay. Here you have a data buffer is there. Data buffer that is present in everywhere 82555 and the 8259. That is for interfacing the data, right? Then input output control is there is one chip select will be there. Then WA0 is checking whether you have to select WR or RD bar. Okay, RD bar is nothing but a read signal. WR bar is nothing but a write signal. Okay, this is the input output control, data buffers and input output control. Next one is FIFO bar sensor run status. So all those things we will see in detail. This is internal data bus. 8. It is marked as 8 now. So this is an 8-bit internal data bus. 8-bit internal data bus. And from internal data bus, it is receiving the data stream control and the timing registers. Then 8 by 8 FIFO bar sensor. FIFO is nothing but first in, first out. Okay, that is FIFO. First in, first out. Sensor RAM. Then keyboard debounce and control. This is return, shift, control, stop signals will be there. Then scan counter, timing and register. timing and control will be there. From control and timing register, it is more, the signal is given to timing and control. Then display register, then 16 by 8 display RAM, and then display address register. Okay, this is the architecture. First you draw the diagram, then we'll move to the explanation part. You take 5 minutes and you draw the architecture diagram. Then we will move to the next part. Did you finish? Guys, did you finish?
Madam, I hope we'll proceed.
Okay. So this is what is interrupt and the polling mode. Okay. Uh, so suppose if you consider me as the CPU, if you were telling that I have completed, ma'am, that is interrupt mode. But we were keep on asking. So what is happening here is always polling. Correct, no, sir? So we are always inquiring. Did you finish? Did you start? Did you complete? Okay.
Now,
So that is polling mode.
now they won't forget the interrupt mode and polling mode, right? Okay, fine. Proceed. Good
This
analysis.
is what it is. Okay. So what this is what is happening in our class. That is, it's only polling mode. There is no interrupting mode happening in our class. Okay. So we are only questioning whether you have started, whether you have completed all those things. Okay. So that is what is interrupt mode and polling mode. Now we'll see each block in detail. Okay. So first one is interrupt output, input output control and data buffer. So that you know already what is input output control and the data buffer. So what is input output control? Data buffer first we will discuss about the data buffer. So what the data buffer will do? It will control the flow of data in and to the microprocessor. That is the data buffer is doing. And also it is interfaces the external bus of the system with the internal bus of the microprocessor. That is nothing but it is receiving data from the external system and it is giving the data to the internal system. Okay, so from the internal system only the CPU is accessing the data. That is what is the data buffer is doing. Then what is input output control? There is A0, RD, WR are used for command rather than data read or write operation. That you know, there is one more signal is there, that is chip select. Okay, so whenever chip select is that is a CS bar signal. So if you are putting 0 to that signal, then only your either the chip will be activated. That is chip selected. Then A0 will select whether you have to do the read operation or write operation. Then everything is negative signals, RD bar, WR are using. So if it is 0 only, read signal will activate, and if WR bar is equal to 0, then write signal will be activate. That is nothing but input output control and data buffer. So this is same as what you have seen in the previous sections also. Now the thing is control and timing register and timing and control. Okay, so there are two blocks where there. These are the two blocks: control and timing registers and the timing and control. So we'll see what is this one. So this unit contains the registers to store the keyboard, display mode, and other operations as programmed by the CPU. So actually, in this keyboard and display, there is two modes. There is one is it will be act as a keyboard, and second one is it will be display. So the control and timing registers, it will be so based on the opcode or the command is received in the control and timing register. It will be select whether it has to be a keyboard or it has to be in the display mode. And all other operations 8279 NN operation memo. So all those operations will be programmed by CPU and it is given to the control and timing registers. And timing and control is if unit this is only handles the timing of the operation of the circuit. So the timing of operation is completely based on the clock cycle, internal clock frequency only. So based on the internal clock frequency, it will control the timing and the control timing of operation of this all the process. Either it is keyboard scanning or it is the scanned things you are given to the display. You are going to display the thing. That's what is doing the keyboard and display mode in the control and timing register and timing and control. Next one is scan counter. Scan counter, this is nothing but the, so from timing and control signal, it is given to the scan counter. Okay, the signal is given to the scan counter. We'll see what is the scan counter is doing. The scan counter, it has a two mode of operation. First one is encoded mode and the second one is decoded mode. So encoded mode means it is externally decoded And the decoded mode means it is internally decoded. That is the difference between encoded mode and decoded mode. So encoded mode means it will be decoded externally, and the decoded mode means it is decoded internally. Okay. So in the encoded mode, the counter provides the binary count that is to be externally decoded to provide the scan lines for the keyboard and the display. And in the decoded scan mode, the counter internally decodes the least significant 2 bits and provided a decode at 1 out of 4 scan of SL0 to SL3. That is nothing but here. So in the scan counter, uh, first one is encoded mode. Encoded mode, what it will do, it is given the complete signal to SL0 to SL3, and in the outside only it will be decoded. What is the signal received from here? Okay, that is encoded mode. Decoded mode, so inside the scan counter itself, it is decoding the signal, and the decoded signal is given to any one of these 4 lines, SL0 to SL3, SL0, SL1, SL2, SL3. So totally 4 lines are there. So it is given the decoded signal to SL0 to SL3. That is scan counter. So the two mode of operation, first one is encoded mode and second one is decoded mode. Now next one is return buffer, keyboard, debounce and control. So this is nothing but this portion. Okay, keyboard return, keyboard debounce and control. Okay, return, keyboard debounce and control. So we are going to see about these two blocks: return, keyboard debounce and control. So what is the keyboard debounce? Return buffer is what all those things will do. So this unit first scans the key closure in the row wise. If found, then the keyboard debounces the key entry. Okay. So what it is actually doing is like we said in the starting itself, it will check for in the row wise. Okay. Once it is detected that it has a key bounce rebound, then it will check in the row wise, and suppose if it is detect something, what it will do? It will given to the keyboard debounce unit. Okay, it is given to the keyboard debounce unit, and the keyboard debounce unit will identify which key has been pressed. That is the keyboard debounce unit uh, will do. So suppose the same key is detected, then the code of that key is directly transferred to the sensor RAM along with the shift and control key status. Uh, so everywhere we are using shift and control, right? Shift 1, 2, 3 like that. Okay, suppose if you want to check the special characters, what you have to do? You are using shift as well as control keys. Okay, so with the shift and control key status only it is sending. And one more thing is uh, it will suppose if you are pressing a key that is for a very minute for a time period, it will not detect a key entry. So you have to be press the key for a particular duration. It is not necessary. It is in the millisecond, microsecond, in that time period only. It is not like in seconds. Okay, it is not necessary to be visible to your eyes. Okay, so it is in the very minute time duration. So you are pressing a key for a particular duration. It will check that what is the status of your shift as well as control key. Okay, based on that only it will detect this key you have been pressed. Suppose you are pressing 1, okay, or 2. 2 is nothing but a up symbol will be there, right? So at the right symbol will be there. So you are pressing the key 2 for a long time, then it will be detected that whether you have pressed the shift or control key. Okay, whether you have pressed any shift key or control key. Then if you have pressed the shift key, it will be consider it as at the rate. Okay, or if what it will do, if shift and control key are not pressed, it will detect it as it as 2 only. That is what is the return buffer, keyboard debounce and control unit will do. Now next one is FIFO sensor RAM and the status logic. So this is nothing but a FIFO sensor RAM and status logic. Now we are going to see about this one, FIFO sensor RAM and status logic. And here also one 8-bit FIFO sensor RAM, and this one is corresponding status logic. Now we are going to see this one. So what is FIFO sensor RAM and status logic? FIFO is nothing but first in, first out. It is a 8-byte RAM where the key code of every pressed key is entered into the RAM as per their sequence. So if you are writing your name, suppose I am writing my name as Vinu, MWNU, first it will sense it will detect the key M, then E, then E, then N and U. Okay. So what it will do, first it will generate the corresponding code for the letter M, then it will generate the corresponding code for E, then again it will generate the corresponding code for E, then it will generate the code for N, and it will generate the code for U. Okay, that is what it is doing. That is 8-byte. Okay, so 8 byte means 1 byte is equal to 8 bit. So the status logic generates an interrupt request after each FIFO read operation till the FIFO gets empty. So if the scanned sensor metric mode, this unit acts as sensor RAM where each row is loaded with the status of their corresponding row of sensors into the metric. So whatever it is in the scanned mode or as well as if you are if you are pressing the key in both ways, it will generate the corresponding code and it is stored in the FIFO register. Okay, FIFO or sensor RAM register. So when the sensor changes its state, its IRQ line changes to high and interrupt the CPU. So the what we will see the IRQ line in the we'll see this IRQ line about this in the pin diagram. Okay. So this is what is the FIFO sensor RAM and the status logic will do. Next one is display address registers and the display RAM. So here till now we were discussing about the keyboard mode only. So now we are going to see the display operation. So display is nothing but the write operation. Okay, this is nothing but the write operation, which is going to display the what it is scanned or censored through the keyboard. That is what is in the display operation will be there. So display address register and display RAM. This unit consists of display address registers which hold the address of the word currently read or written by the CPU to or from the display RAM. This is nothing but display RAM and display address registers. Okay, so this portion carries the display, and this portion carries the nothing but your keyboard scanning, and this is display unit, and this is keyboard scanning unit. So keyboard display RAM, whatever is given by the CPU, either it can be read instruction or write instruction, whatever it is there, it is displayed through the register. And you suppose if you're connecting some display devices, you can see what is the signal or what is the key. It has been pressed through the keyboard and it is displaying through the display registers. That is what is the display RAM as well as display register. Display register is nothing but it will hold the address of the word, and the display through the display RAM, it is going to display the actually signal or the number or key or press the key, whatever it is going to display through the display RAM. So this is what is about the block diagram of the 8279. So 8279 block diagram, it is a bit confusing. So anyway, you have to study that. You have to draw the diagram neatly. Then only you can. Then actually that is the most important thing. Okay, even if they are asking explain about the block diagram, you have to draw the diagram. Then you have to explain. So if you draw the diagram, you may get the half mark. Okay, suppose if it is an 8-mark question, you will definitely get 4 marks for the drawing diagram, because diagram is most important, and you have to write the explanation corresponding. Now we will see the pin diagram. Pin diagram. This is a 40-pin IC. Then there is RL1 to RL2, RL0 to RL7. So totally 8 pins will be there for that. Then out A0 to A3, then B0 to B3, Then DB0 to DB7 is a data bus signal. Then SL0, that is SL0 to SL3, that is for the scan counter. It is using for the scan counter. So we will see each and every signal in detail. Okay. So first one is data bus lines, that is DB0 to DB7. So that is nothing but the internal data bus. Okay, it is a bidirectional data bus. So you can send the data or it can receive the data. So that is a bidirectional data bus, that is DB0 to DB7. That is here shown from here, DB0 to DB7. That is nothing but the bidirectional data transfer. Then clock is internal timings required by the microprocessor, generate internal timings, because based on the clock signal only it is controlling. The control and timing unit will work. Okay, so the clock has to be given. Then reset pin is used to reset the microprocessor. It will reset whatever data will be there. It will be reset all the values. That is what is the reset pin will do. So you suppose if you were in our lab, you can see what the reset will do. Okay. So that is what is the reset pin will do. Next one is chip selector. Chip selector is nothing but then if chip select is zero only, then only the IC will be working. That is chip select signal. Then A0 the command or status information. When it is low, it indicates the transfer of data. That is A0 signal. RD and WR, that is read and write the pins. That also you know. You have to send the data or receive the data. That is read and write command. Then IRQ is nothing but the interrupt output line. Okay, this is IRQ is nothing but the interrupt output line. It goes high when there is a data in the FIFO sensor RAM. FIFO sensor RAM, when it has data, when you are pressing a key, okay, it is an 8 byte register. So when it is filled with the data, then IRQ is go high. Then the interrupt line goes low with the FIFO RAM read operation. And if the FIFO RAM further contains any key code entries to be read by the CPU, this pin again goes high to generate an interrupt to the CPU. So you are pressing a key, okay, you are pressing the key, so the FIFO RAM will be filled with the data or the corresponding code of that particular key entry. Okay, then what you have to do, you have to inform the CPU that the user has entered these data and you have to read my data. Okay, it has to be informed the CPU. So, so that communication is carried out through the IRQ line. So whenever the IRQ line is high, what does it mean? Whenever it is high, it is CPU knows that you have entered some data and I have to collect the data from the FIFO RAM. Okay, that is what is the IRQ line will do. Then VSS and VCC. This is nothing but your power supply signal. VCC is your positive supply. VSS is the ground signal, or the based on the construction, based on it can be either 0 or -5 volt. So mostly it will be 0 only. VSS we are putting as ground only, but sometimes in the data sheet it may be mentioned that you have to give the -5 volt. So based on that, you can put it as VSS. If it is ground, you can directly tell that it is 0 only, but VSS you cannot exactly tell that this is 0. Okay, so that is VSS and VCC. Now next one is SL0 to SL3. What is SL0 to SL3? SL0 that you have seen in the scan counter, right? So these are the scan lines used to scan the keyboard metrics and display the digits. So these lines can be programmed as encoded or decoded using the mode control register. That also you have seen in the previous class section, right? Next one is RL0 to RL7. That is, these are the return lines which are connected to one terminal of keys, while the other terminal of the key is connected to the decoded scan line. So these lines are set to 0, then any key is pressed. Okay, that is nothing but the return lines. RL0 to RL7 is nothing but the return lines. Next one is shift. Shift input line status is stored along with every key code in FIFO in the scanned keyboard. That also you know what the shift will do. Then still it is pulled low with a key closure. It is pulled up internally to keep it high. Okay. So shift also, what is the shift will do. It will, the FIFO is every time it is checking whether the shift key is pressed or not. Next is control stopped input output mode. Control STB. STB is nothing but stopped. So in this keyboard mode, the line is used as a control input and stored in FIFO on a key closure. So the line is a stop line that enters the data into FIFO RAM in the stopped input mode. We will see the stopped input. What is the stopped input? Our input mode is divided into three modes of operation. So we will see the input mode. What is stopped mode? That we will see. Then it has an internal pull up. The line is pulled down with a key closure. That is control and stop. Then BD is blank display. Okay, if the BD bar, so whenever if it is zero, what it will do? It will make the display as blank. That is BD, blank display. Used to blank the display during digital switching. Then out A0 to A3 and out B0 to B3. So these are the output ports for two 16 by 4 or one 16 by 8 internal display refresh registers. So through this one, the internal display registers is connected through the display device using data out A0 to A3 or B0 to B3. Either it can be used as a single 8-bit display line, or you can use it as a two port. Out A0 to A3 one port, that is 4-bit port, and second one is again 4-bit port. So this is what is about the pin diagram of your 82799. So you can draw the pin diagram, then we will move to the mode of operation. I hope you understood. So the thing is, you have to read it very carefully.
Madam, can you go full screen?
Okay, sir.
Shall we proceed, guys? I suppose the spin diagram has been copied down. Hope we can proceed. Yeah. Okay, fine. Madam, you can proceed with the next topic.
Okay. Now we are going to see the modes of operation, operational modes of 8279. So there are two modes of operation. First one is input mode and second one is output mode. So input mode is three input modes are there. First one is scanned keyboard mode. Second one is scanned sensor metric, and third one is stopped input. So we'll see one by one. Okay. So first one is scanned keyboard mode. So what is happening in the scanned keyboard mode? The key metrics can be interfaced using either encoded or decoded scan that you already know. Okay, what is encoded and what is decoded? Encoded means external decoding and decoded is nothing but the internal decoding. So in the encoded scan, 8 by 8 keyboard or in the decoded scan, a 4 by 8 keyboard can be interfaced. So the code of key pressed with the shift and control status is stored into the FIFO ROM. That is a normal operation only, the scanned keyboard mode. So either it is in the encoded scan or in the decoded scan. If it is encoded scan means it is using a 8 by 8 keyboard, and if it is a decoded scan, it is using 4 by 8 keyboard. That is interfaced with the system. So it will check the FIFO RAM. It is going to check whether the key is pressed with the shift or control status. Okay, that is the scanned keyboard mode. Second one is scanned sensor metric. In this mode, a sensor array can be interfaced with the processor using either encoder or decoder scan. In the encoder scan, it is an 8 by 8 sensor metric, or with the decoder scan, it is a 4 by 8 sensor metric can be interfaced. So that is nothing but a matrix. Matrix means it is either 8 by 8 matrix or it is a 4 by 8 matrix. 8 by 8 matrix means it has 8 rows and 8 columns. Okay. So suppose if it is sensor key pressed, what it will do? It will check which row it has been selected. Okay. And then it is going to check which column it is the key has been pressed. So based on that, it will be sensing that this key is pressed. Okay, the particular key is pressed. That is in the sensor matrix. Then next one is stopped input. So stopped input mode, the control line is set to 0. The data on the return line is stored in the FIFO byte by byte. Okay, so this is nothing but using a keyboard or keyboard or a sensor matrix. What it is doing, we are making the control line as set as 0, and the data return lines, you have return lines, like what are the return lines? That is RL0 to RL7. These are the return lines. So whatever data is available in the return lines, it is stored in the FIFO RAM. It is not. So it can be from somewhere else also. Okay, it is stored in the FIFO RAM. That is stopped input. So these three are the input mode of operation. That is, first one is scan the keyboard mode, second one is scan the sensor metric, and third one is stopped input. Similarly, there is output mode is there. So the output mode is display, scan, and the display entry. That is, output is nothing but the display. Input is nothing but the keyboard. Okay. So output mode is display scan. So this mode allows 8 by 16 character multiplexed displays to be organized as dual 4-bit or 4-bit or single 8-bit display unit. So display scan, it is the data it has been received from the keyboard scan, right? So it is given to the display unit. That is display scan. Then display entry, data to be entered for display either from the right side or left side. That is actually while writing in the microprocessor, while you are writing, what you have seen is you can when you are pressing key, first digit will be displayed. Okay, when you are pressing the next key, the first digit is moving to the right side and the second number is coming. Okay, like that. That is the display entry. Display scan, it is multiplexed and it is given at the same time it is giving the complete display, and display entry it is writing, it is from left to right or right to left. Okay, in the calculator, that all those things are like that only. Okay, so that is the display entry and display scan and display entry. So these are the modes of operation: input mode and output mode. So input mode, three modes of operation: scanned keyboard, scanned sensor matrix, and the strobed input. These three are the input mode of operation in the 8279. Then output mode is nothing but display scan and display entry. These are the output mode of operation. Uh, so this is what is 8279. Hope you understood about 8279. If you have any doubt, please let me know. Otherwise, we will move to the next topic. I hope we can move.
Yes,
Shall
madam,
we
we'll
move,
proceed to the
sir?
next. Yeah, we'll proceed to the next topic.
Okay, okay, sir. Now we are going to see the interfacing. Sir, can you mute it? No. Okay. Now we are going to see the microprocessor interfacing. So first we will see what you mean by interfacing. Interfacing is the path for communication between the two components. Okay. You are interfacing. Uh, you want to communicate. You want to connect to two peripherals. It is called as the interfacing. You are communicating from peripheral devices and the microprocessor. That is interfacing. You are interfacing with the microprocessor. Okay, your printer is interfacing with your CPU. Okay, or the keyboard is interfaced with your CPU. Like that, it is the way of communication between the two systems. That is interfacing. So there are two types of interfacing. First one is memory interfacing, and second one is input-output interfacing. Uh, this is the block diagram of memory and the input output interfacing. Okay. So what is this? You have totally three buses. Okay. First one is address bus. Address bus carries the address of the location. The data bus carries the data. Then next one is control bus. Okay. Control signals will be carried out in the control bus. So memory, so all those things are need to be uh, um, what to say, needs to be operated with the memory interfacing as well as input output device interfacing. So memory interfacing, since that time also it has to be used address bus, data bus and control bus, and input output device also it has to be uh, use both all the three buses: address bus, data bus, and control buses. This is just a simple block diagram of the memory and input output interfacing. In both the interfacing, it has to be used the microprocessors, address bus, data bus, and the control bus. It has to be used. So that is nothing but the memory and input output interfacing. So the interfacing pins which are available, the higher address bus A8 to A50 means nothing. Totally, it is a 16-bit address that you know. This is a 16-bit address. So that is from A0 to A50. So A0 to A7, A0 to A7, or you can call it as AD0 to AD7. So the lower part of this address line will be act as the data bus. Okay, it will be act as both as data bus as well as the address bus. If it is a 16-bit address, what to do? The A0 to A15 will be used. If it is an 8-bit, it will be using based on the signal, whether it has to be used the address or data. It will be used, if it is an 8-bit address, it will be using A0 to A7. If it is a 16-bit address, it will be using A0 to A50. And AD0 to AD7, that is nothing but A0 to A7 only. It will be act as a data bus also. Okay. Based on the control signal, it will be act as either address bus or data bus. Okay. So these are the interfacing pins. Then ALE is nothing but address latch enabled. RD is read command signal. WR is write command signal. then ready, whether a CPU or processor is ready or not. So the ready signal. These are the interfacing things which are there in your 8085. Okay. So main thing is address and data bus lines A0 to A50. So this is a 16-bit address. So A0 to A15 is nothing but your address lines only. But A0 to A7 can be acted as both address and data bus, because this is a 8-bit data bus. It is an 8-bit data bus and 16-bit address bus. These are the 8085 interfacing pins. So memory interfacing we have to see in bit detail, because with the memory interfacing you are going to see what is the address decoding. So that we will see. So in input output interfacing is nothing but you are communicating with the peripheral devices like the keyboard, printer, mouse, so etc. Okay, whenever you are connecting these peripheral devices with your microprocessor, it is called as a input output interface. So we need to interface the keyboard and other devices with the microprocessor by using latches and the buffers that you see, because we have already seen about the interfacing units, that is 8279 keyboard interfacing. Then what to say, programmable peripheral interface. So different peripheral interface units we have seen. So all those things will be used for the input-output interfacing only. So this type of interfacing is known as the input-output interface. So if you are connecting some peripheral devices with your CPU, you can call it as an input-output interface. Okay, that is what is interrupt input-output interface. Now we will see what is a memory interface. So what is memory interfacing? When we are executing any instruction, we need the microprocessor to access the memory for reading instruction code and the data stored in the memory. For this, both memory and the microprocessor require some signals to read from and write to the register. So the interfacing process includes some key factors to match with the memory requirements and microprocessor signals. The interfacing circuit therefore should be designed in such a way that it matches the memory signal requirements with the signal of the microprocessor. So the memory interfacing is nothing but you have to store the data from registers to memory. What is memory? You have RAM, ROM. So all these things are your memory. Okay. And it has some internal registers also. So this internal registers data you need to be storing the memory location. So while storing the memory location, what you require some instructions from the microprocessor. Okay. So these signals you can call it as a memory signal. Okay. So you have to store these data into the particular memory location, or you have to retrieve the data from the memory location to the corresponding register. Okay, that you have seen different addressing modes and all. Okay, you have seen different addressing modes, how to store the data, how to retrieve the data. So you have seen the different addressing modes also. Okay, so these are known as the memory interfacing. While you are interacting with the memory of the microprocessor or CPU or the computer, whatever it is, you can call it as a memory interface. So when the working unit is interfacing with the peripheral devices, you can call it as the input-output interface. Okay, this is the difference between input-output device, input-output interfacing and memory interface. Memory interfacing means the CPU is accessing the memory, or it is storing the data or retrieving the data. That is what is the memory interfacing. But input-output device is nothing but it is communicate with the peripheral devices like the keyboard, mouse, printer, then joystick. There are so many signals, so many X-ray plotter, so many things are there. No? So it is nothing but it is communicate with the peripheral devices. You can call it as a input-output interface. So actually, what is the requirement of this memory structure? This memory structure, it should be an n by m size. Okay, the n is the number of register and m is the word length. So suppose if you are calling it as a 8 by 8 or 8 by 4, where 8 is the number of register. So 8 registers should be there, and each register is size of 8 bit. Suppose if it is 8 by 8, okay, it has to be 8 registers will be there, and each register is of 8 bit size. That is nothing but the word length, okay, or in the number of bits. This is what is the size of the memory. So we'll see n by m, where n is the number of registers and m is the word length in number of bits. So it here actually it is showing two internal memory. First one is RAM and second one is ROM. ROM we are using EEPROM. Okay, erasable PROM. We are using EEPROM, and this is RAM memory. So RAM memory, it is a size of 2048 registers with the 8-bit length. Okay, so it has 8. It is not necessary to be the same. Okay, it is just giving an example like 2048 is the number of registers will be there in the RAM location, and 8 is the corresponding bit size. Here it is 4096 registers will be there, and 8 bits are there. So you know that while seeing the configuration of your system, if you know that what is the size of your configuration, what is RAM size and what is ROM size, okay, that you can see. That you are seeing in the while seeing the configuration of your laptop, you can see what is the size of your system. Okay, that is nothing but the RAM as well as the EEPROM. So there are some basic concepts in the memory interface. Okay, so this is a 64-byte memory because we are addressing this is a 16 bus. Okay, it is a 16 bus. It is using a 64K byte, and it is not necessary for 8085 only. We are saying for 8085 it is a 64K byte memory location will be there. But it is not necessary we have to use the complete 64 kilobyte. It is not necessary use. It can be some empty spaces also will be there. It is not necessary to be used all the 64 kilobyte. So generally we are using EEPROM as well as RAM for as the data memory. ROM is the program memory and RAM is your data memory. The total, so this is the total memory. EEPROM plus RAM is the total memory. So this total memory will be located in the 64 kilobyte. Okay, it is not necessary to be used the same thing, but it must be within the 64 kilobyte. So it is the EEPROM and the RAM will share the total address space of 64 kilobyte. So and the capacity is based on the application. Okay, based on the application whether you have to use the 64 kilobyte or not, based on the application only. So you, and also one more thing is it is not necessary to be one EEPROM and one RAM. It is not necessary to be like that. You can use a multiple number based on the requirement. You can use a multiple number of RAM as well as EEPROM. Okay. Then another point is EEPROM as well as RAM you can keep anywhere. It is not necessary from 0 to the last bit. It is not necessary to be like that. But one thing is EEPROM we are starting with the address 0008. So why we are doing this 008? We are starting with 0008 means once you are resetting the address, it will be go back to 000. Okay. Suppose if there is, if your EEPROM is located in somewhere else, you have to go to that location. Okay. It is not resetting the EEPROM. So that's why we are calling it as 0008. We are starting the EEPROM from 0008. And suppose EEPROM is located for the location from 000 to 0FFH, then that is the total size of your EEPROM. And the RAM has to be started with the 100. Next number is 100, right? So RAM is not necessary to start from 100. It can be start anywhere in between FFFH. Okay, 10008 and FFFH. That is the last word. Okay, that is the address of the last word. FFFH. That is 64K. And 00 is the starting address, and the FFFH is the ending address. So it has to be anywhere in this location. But usually EEPROM will start from 000, and based on the size of the EEPROM, it can be 0FFH. or it can be 2FFH based on number of EEPROMs you are using. Okay, so it is not necessary to be in this location. But it is not necessary to be start the RAM location at 100. You can start anywhere in between 10000 to FFH. Okay, this is what is the basic idea about your memory interface. So memory interfacing in 8085, you have 60 kilobytes is memory is available, and it is shared by EEPROM as well as RAM, and it is not necessary to be used one EEPROM or RAM. You can use multiple EEPROM and RAM. It is based on the your program. Okay, so requirement based on the requirement, you can use multiple, and the address also you can use everywhere. It is not a problem. Okay. Now the memory interfacing, it has to some requirements. So the first one is select the chip. Second one is identify the register and enable the appropriate buffer. So the microsystem processor system includes memory devices and input-output devices. So it is important to note that the microprocessor can communicate with only one device at a time, since the data address and control buses are common for all the devices. Then in order to communicate memory or input-output devices, it is necessary to decode the address from the microprocessor. Due to this, each device can be accessed independently. So the main thing what it is given here is the microprocessor can communicate at a time to one device. Either it can be memory or one input-output devices. You can use one devices at a time. Okay. So what it has to do, it has to decode the data address of the device or the peripheral device or memory. It has to be decode the address, and the corresponding address only the microprocessor is going to communicate. That is the interface. So it select the chip, then identify the register and enable the appropriate buffer. So that is based on whether it has to communicate with which peripheral device it has to communicate. So based on that only, the appropriate buffer is going to enable. Then address decoding, actually there are two types of address decoding are there. First one is full decoding, second one is partial decoding. Full decoding is called as the absolute decoding, and partial decoding you can call it as a linear decoding. So while writing address decoding methods, you can write it as a full decoding and partial decoding. Then in bracket you may given that absolute decoding and linear decoding. It is not a problem. Which way you can put it, but it is easy to write full and partial, full decoding and partial decoding. Now this is what is absolute decoding, full decoding. Okay, here you are using one EEPROM is there and one RAM is there. Okay, so what is happening in the full decoding? The chip EEPROM is one chip, right, and the RAM is another chip. The chip is selected using a decoder circuit. Okay, the chip is selected using a decoder circuit where the upper bits of the address line. Okay, upper address line, that is A13, A14, and A15 will have a different combinations, and based on that it will select which from or which memory unit has to be selected. Based on this, it will choose which memory unit it has to be selected. It is Y0, Y1 are there, then it is given to chip select signal and both the chip select signal. So based on this one, all the three upper address lines, okay, all the three upper address lines will select the corresponding memory unit. Okay, it will select the corresponding memory unit, and this is nothing but this is write, read, and input output memory command. Okay, so based on this, it will select where it has to be connected, read or write to EEPROM or RAM. Okay, it is based on this decoder. It will select the corresponding EEPROM and RAM. And this full decoding will be used for the larger system. If it is a smaller system, we are not going to use the full decoder. It is going to be used only for the larger system. Okay. So in an absolute decoding technique, all the higher address lines are decoded to select the memory chip, and the memory chip is selected only for specified logic levels on these higher order lines. No other logic levels can select the chip. So this addressing technique is normally used in the larger memory system. That's what we have seen. Next one is linear decoding or the partial decoding. So in the linear or partial decoding, here you see apart from the previous one, so this block will be same for a full and partial decoding. But here you are not using any other decoder circuit. Okay, here because you are using only A15 address line to use the chip selection. So A15 line is 0, then this one will be EEPROM will be activated. So it will select the use EEPROM only, it will select. If A15 is equal to 1, RAM will be selected. Okay. If A15 is equal to 0, EEPROM will be selected, and if A15 is equal to 0, 1, RAM will be selected. That is what is happening in the linear decoding, or you can call it as a partial decoding. And this is used in the small system. Hardware for the decoding logic can be eliminated by using individual higher order address line to select the memory chip. It reduces the cost of the decoding circuit, but it has a drawback of multiple addresses or shadow addresses. Here, A15 address line is directly connected to the chip select signal of EEPROM, and after inversion, it is connected to the chip select signal of the RAM. Therefore, when the status of A15 line is 0, EEPROM gets selected, and when the status of A15 line is 1, RAM gets selected. So the status of the other address line is not considered, since those address lines are not used for the generation of chip select signal. Okay, that's what we have seen. Only A15 signal is used for the chip selection of EEPROM or RAM. Based on A15 signal, you are using whether it is used for EEPROM signal. EEPROM has to be selected or RAM has to be selected. And one more thing is there in the input-output interface. That is nothing but communication. There are two ways of communication will be there. That is serial communication and parallel communication. So this is along with your input-output interfacing. It will come with along with the input-output interfacing. That is serial communication as well as parallel communication. Serial communication is sending data bit by byte of data, bit by bit. For example, you are using telephone modem, right? Using telephone modem, you are connecting serially. So you are sending one bit at a time. Okay. So actually, you know that what is the baud rate will be there, how much data you are sending. Okay, how much in a particular second, 1 second, how much data you are sending. That is nothing but baud rate and all. So that is serial communication. Parallel interface is parallel interface means you can transfer multiple data at a time. Okay. So suppose if you consider a 1 byte data, 1 byte is 8 bits, right? So 8 parallel lines will be there. So you are sending 1 byte at a time. Okay. So it will take only 1/8 of the serial communication in the timing. Okay, that is what is serial communication as well as parallel communication. So your parallel communication, you are sending data simultaneously. Serial communication, you are sending data bit by bit. So this is what is about the interfacing. So what we have seen today, we have seen about the 8279 interfacing we have seen. Then we will see interfacing about memory interfacing as well as input-output interfacing. Memory interface, what are the interfacing pins we are using? Then input IO interfacing, what is IO interfacing? There are two ways of communication, one is serial and one is parallel communication. Then memory interfacing. Memory interfacing, actually we are using EEPROM as well as RAM for the memory. There are two types of interfacing will be there. Sorry, in the decode address decoding is there. One is full decoding, one is partial decoding. In the case of full decoding, what is doing? You have you are using three address lines for identifying the memory location, and what to say, and also it is used for the larger system. And partial decoding or linear decoding, we are using it for smaller system where only one address line is used to identify the corresponding memory location. This is what we have seen. This is about your module 3, and only two topics pending here is, so we have completed up to this one. Okay, programmable interrupt controller. The topic which is pending is developing simple application using 8085 microprocessor. So that is, there are two techniques. The one is stepper motor control and the traffic light control will be there. And another one is introduction to 8086 microprocessor. I think we can finish it off by next Saturday, coming Saturday. Hope so. Correct, no, sir? I think we can do it.
Okay. So, having said that, we have completed till the 8279, which is the keyboard display today, and that completes our close to 80% of our module 3. Right, left out are only two topics. As said by Madam, it is only a stepper motor control and a traffic light control application using 8085 and introduction to 8086. Right, so we are going to see this introduction to 8086 on Saturday. Coming Saturday, first hour, we will complete that introduction to 8086, where we will see the features as well as the architecture part. Right. In the course of time, in today's afternoon class, we will be focusing on the lab component of microprocessor. Last week itself, we have said you what we are going to use. I don't know whether you have looked into that particular simulator. Since I didn't get any response, I thought you might have got engaged with some other work. So we'll just see to it that today afternoon, between 2 to 3:30, I'll show you from where to pick up that simulator, how to in your program, how typically when you are in a microprocessor lab, what is that kit that you will be seeing. So all those things will be able to get it demonstrated, right? So that's a plan for the day. And there are few people who have missed unit test 2 for some reason. You will have to get back to us by today afternoon 1:30, and if the reason is valid, you can take the test by the end of the day today itself, right? Because today we are going to submit the marks to your tutors. Okay, those who are absent for the unit test. Assignment 3 for module 3, there will be 4 questions and that will be posted to you by end of the day. Submission is by the Sunday. 4 questions. By Sunday evening you can submit it. Is that fine? So hopefully in the next few classes we might be in a position to complete module 3. Then we'll have a revision of a few problems in module 1 and module 2. Okay. If there is any other clarifications, do let us know. If there is any topic which you want us to take again, other than the analytical problem area, which we'll be seeing, starting from K-map and with synchronous, asynchronous, analysis and design, all those things we'll be seeing in next week also, because we have few classes in the next week also. Tuesday, 2 classes are there. That time also we'll be able to see those classes, right? Adding to that, if there is any doubt, let us know. Fine. That's it from me, madam. If you have got anything to say, you can. 10:55.